Welcome to The Explainer. Have you ever really stopped to think about what happens after you eat a meal? I mean, what really happens? Today, we're going to follow the incredible, winding journey your food takes from the moment it's on your plate to how it powers every single thing you do. Let's dive in.
So first things first, let's meet the absolute hero of this whole story, a molecule called ATP. The easiest way to think about it is like this. Your body is full of trillions of tiny rechargeable batteries. That's ATP. Literally everything you do, blinking, breathing, thinking, you name it, is powered by these little batteries. Your body's entire mission really is to keep recharging them with the fuel you get from food.
So here's our game plan for today. We're going to start with the big picture of energy, then we'll meet our main fuel sources. After that, we follow the super important journey of two different sugars, and we'll finish up by seeing where all that excess energy ends up. Okay, before we get into all the nitty-gritty details, let's just zoom out for a second. Your body, all day, every day, is managing this incredibly complex energy budget. You can honestly think of it just like managing your own bank account. Now here's what's so fascinating. Your body is almost never in perfect balance. When you're eating, you're in what's called a positive energy balance. You're making a deposit, taking in more energy than you're spending. But for all the other hours of the day and night, you're in a negative balance. You're making withdrawals. This back and forth, this seesaw, is happening constantly.
And this is the key takeaway. It's not those little ups and downs throughout the day that really matter for your weight. It's the long-term trend. If you consistently, over weeks or months, take in more energy than you spend, that's what leads to weight gain. And of course, the opposite leads to weight loss. Your body is always trying to find its way back to that steady state.
Okay, so where is all this energy actually going? The answer usually surprises people. The huge majority of it, we're talking up to 75%, is spent on your resting metabolism. That's just the energy it takes to keep the lights on, keeping your brain running, your blood pumping, even repairing cells while you're asleep. All that energy you think about spending when you exercise, that's actually a much smaller piece of the pie. All right, so we get the budget, but what's the actual currency we're using in that budget? Where does the energy come from? Well, let's meet the main characters in our story.
For this explainer, we're going to focus on the two big players when it comes to fuel, carbohydrates and fats. Their chemical structures are totally different, and that's what defines their roles. Carbs are basically long chains of sugar, which makes them perfect for quick, easy-to-access energy. Fats, on the other hand, are built to be a much denser, long-term energy reserve. Think of carbs as cash in your pocket, and fats as money in the bank.
And this is where our journey gets really interesting. When your body breaks down carbohydrates, you're left with simple sugars. But, and this is a huge but, not all sugars are treated the same way by your body. This is a major fork in the metabolic road. You see, the process for carbs happens fast. Digestion actually starts right in your mouth. As the food moves through your system, enzymes chop up those long chains into simple sugars. Those sugars then get absorbed directly into your bloodstream, and that's like an alarm bell going off, signaling your pancreas to release a really important hormone called insulin.
Okay, so the two most common simple sugars are glucose and fructose. And I can't stress this enough, their paths inside your body could not be more different. Glucose is the universal fuel. It's like an all-access pass that can be used by pretty much any cell in your body for energy. Your brain especially runs on it. Fructose, though, it's got a one-way ticket, and that ticket goes straight to the liver. This difference is absolutely critical to understanding how our bodies handle food.
So let's follow the glucose first. Your body is in this constant, delicate balancing act with it. If you have too little glucose in your blood, your brain cells can actually die. But if you have too much, it's toxic to your tissues. So this is where insulin comes in. It acts like a traffic cop, directing the glucose exactly where it needs to go to keep your blood levels in that perfect, just right zone. And where does most of it go? Well, a full 80% of the glucose from your meal is immediately snatched up by cells all over your body. Your brain, your muscles, your organs, and it's burned for fuel on the spot. It's used to recharge those ATP batteries right away. The other 20%, that chunk gets sent to the liver. The liver then converts it into a short-term energy stash called glycogen. But here's the catch. The liver's storage space for glycogen is pretty small. So if that storage is already full, any extra glucose that shows up gets converted directly into fat. All right, now let's circle back to fructose. Remember, unlike glucose, it can't be used by most of your cells. Its journey is almost exclusively to the liver. And since the liver can only use so much energy at one time, any extra fructose that comes in gets converted into fat very, very efficiently. This direct-to-fat pathway is a huge reason why the type of sugar you eat matters so much. So this brings us to the final stop on our tour. Whether it came from that extra glucose or from fructose, we now have brand new fat created in the liver. The big question is, where does it go from here?
While the liver packages this fat up, loads it onto transport molecules, and sends it out into the bloodstream. And its destination? Specialized cells called adipocytes. We just call them fat cells. A typical person has tens of billions of these things, and as more fat arrives, each individual cell just gets bigger and bigger, kind of like a tiny balloon being inflated.
But it turns out, not all fat storage is the same. Where these fat cells are located in your body is incredibly important. Most fat is stored right under your skin. That's called subcutaneous fat. But some of it gets stored deep inside your abdomen, where it gets packed in and around your organs, and that is called visceral fat.
And that brings us to our final and maybe most critical point. The location of this visceral fat isn't just about how you look. These deep fat cells actually behave differently on a biological level than the fat cells under your skin, which is exactly what makes them a much more serious risk to your health. So the question I want to leave you with is this. What is it exactly about the behavior of this hidden fat that poses such a unique threat to our long-term health?